Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Would you like a cookie, Dr. Tot? Yes, okay. And thank you for joining me today. We're going to talk about, and welcome to Algebra II, that's what I wanted to say. We're going to talk about factoring again this week. I wanted to really hone in on the more complex form of factoring when the leading A coefficient is not equal to 1. And then towards the latter end of the week, sessions 2 and 3, we're going to hit on completing the square. That's when you can't factor in the current form. You can rewrite it using an expression, b over 2 quantity squared, in order to convert the quadratic form, quadratic equation into one that is factorable. And in fact, it factors into a perfect square binomial. And then we're going to go from there talking about the vertex form of a parabola and how to translate, transform it, so on and so forth. Let me share my screen with you, and while I do that, I can invite you to like and subscribe to my channel. If you find these videos helpful, please hit the like button and subscribe. So these are live sessions, of course, so there is a little bit of a delay with the iPad. I'll keep track of that. If there's any confusion, or if you need me to scroll up or down, or you have any questions, please just chime in. You can ask questions in the live chat feed, or if you're watching this recording, feel free to drop a comment below. Let's review the standard form of a quadratic. So that's ax squared plus bx plus c is equal to 0. A is termed your leading coefficient, and how you determine which is A is that it's the one that's attached to the squared x. So it can be out of order. They can put the c value first, or they can put the bx value first, but you can identify it strictly by the degree of the variable it's multiplying into. So the value that is next to the number that is next to the x squared variable is going to be indicative of your leading coefficient. Also know that the input variable is just standardly known or referred to as x in math, but it can be any letter. So it could be M, Z, A. In the standard form, we usually use x, but just know that in your problems, in your math classes, your teachers might use a different variable. So we know that because of the additive, or excuse me, because of the commutative property of addition, we know that order doesn't matter, so we can flip these monomials. Ax squared is a monomial, bx is a monomial, c is a monomial. We can flip them around in any order, and it doesn't matter because with addition, order doesn't make a difference. So just make sure that you're able to identify the a value. If the a value is 1, then the factoring strategy is pretty straightforward. We're looking for two factors of the c value, the constant value, that add together either as positives and or negatives in any combination, any positive negative combination, add together to get the b value. Two factors of c that add together to get b. So we have a few examples here. Also remember that foiling is the opposite of factoring, and so you can use foiling to check your factoring process at the end to make sure that you got the correct answer. So let me do number 1 with you just as a refresher, and then I'll let you loose on 2, 3, and 4. So here we have ax squared plus bx plus c is equal to 0. If we just compare this given quadratic equation to the standard form, we can see that a is equal to 1, b is equal to -2, and c is equal to -15. In factoring here, I'm looking for two factors of 15 that add together to get -2. When considering the factors of a number, start with 1 and the number, so 1 and 15. You're going to work your way up on the left-hand side. As you do, the factor on the right-hand side will go down, will decrease. You'll get to a situation where the difference between the bottom two factors is very small, and there's only a limited range of values that lie between those factors. That's a really helpful way of systematically listing out all factors to consider. 15 is pretty straightforward. There's only two sets to really concern ourselves with. But if we had a larger number like 240 or 2,400, so on and so forth, there's going to be a lot of factors, and just shooting at random numbers and checking if the value is divisible is not really an effective way of making sure we get all of an exhaustive list of factors. So after 1, there's 2. 15 is not divisible by 2 because 15 is an odd number. So I'm going to move on to 3. 3 times 5 is 15, so 3 and 5 are a factor pair. 3 and 5 are factors of 15. Notice that the difference, or not the difference, but the only number that lies between 3 and 5 is 4. 15 is not divisible by 4. So because I've come to this condition that I've checked all values that lie between the bottommost factor pair, I know that I have an exhaustive list of all factors. So that's helpful. That's a little hint. So I know that I have all the factors here because 15 is not divisible by 4. And so I'm looking for 2 numbers that would add together in such a fashion, being either positive or negative, to get -2, and multiply together to get -15. Notice that 3 and 5 would work. The larger value will take the sign of the b value because you need the value with the larger magnitude to take over the sign of the smaller value if you're taking the difference. If one has to be positive and negative, which we can see is the case because the c value is negative, the only way for that c value to end up as negative is if the last term times the last term are alternate signs, because we know that a negative times a negative will make a positive, and a positive times a positive will also make a positive. So the only way to get a negative result from the product of the last times the last when we're foiling out is if one is negative and the other is positive. We can get -2, a sum, adding, sum means adding. We can get a sum of -2 by making 5 negative and making 3 positive, because -5 plus 3 is a -2. So I factor this by start by writing out a pair of parentheses. And now I'm going to take the x squared value and I'm going to distribute it in the first position of each parentheses. Now because the leading coefficient is 1, I don't have to worry about any factors of a. This is just going to be x times x, because when we FOIL out, x times x is x squared. That gives me back the value that I started with in the leading position. Now I'm going to place the factors of +3 and -5 in the right positions. When a is equal to 1, when we're talking about the simpler version of factoring, I don't really need to worry about the order of or the placement of where I put -5 versus +3, because the inner times inner and outer times outer values that end up adding together to produce the b value, they don't have leading coefficients in front of the x's, so they're not affected by anything when they're multiplied together. When a is not equal to 1, the harder version of factoring, that's when we have to massage the value. We have to take into consideration what's going to happen when we FOIL out to get that b value, and we reduce the value by that coefficient, or in other words, we divide the factor by that coefficient. But here you don't have to worry. So the answer, the factored form is going to be x plus 3 quantity times x minus 5. If we were to FOIL out here, we could check our answer. Remember, foiling is first times first, outer times outer, inner times inner, last times last. So first times first would be x times x. Outer times outer would be x times -5. Plus inner times inner would be 3 times x. And last times last would be plus 3 times -5. Notice that that gives us back x squared minus 5x plus 3x minus 15. And -5x and positive 3x combine into a -2x. So we get back the exact equation that we started with. And so that's a check. So your answer, this guy would be your answer in terms of factoring the quadratic. If, and I didn't ask you to solve, but I just wanted to point this out, because we have two products set equal to 0, we can use the principle of zero products here. And if I asked you to solve, you would simply set each of the factors equal to 0, and you would obtain two possible outcomes or outputs for x. So subtracting 3, we'd find that x is equal to -3. Adding 5, we'd also find that x would be equal to +5. So if I asked you to solve for x, which I could have, x would be equal to -3 and +5. But as it's listed, I just asked you to factor, so I'm looking for this form right here. If there's any questions, then please let me know. Otherwise, I'm going to give you 5 minutes. I'd like you to look at 2, 3, and 4, and then we'll go through the solutions and then move on to when a is not equal to 1. I'll keep track of the time in the upper right-hand corner, and I'll update it every minute. Okay, so looking at number 2, we have x squared plus 2x minus 3 is equal to 0. So our c value is 3, which is pretty lucky because it's a prime number, so only 1 and 3 are its factors. So we start off by just drawing our pair of parentheses. We're going to assign x to the left-hand position. And now we need two factors of 3 that add together to get positive 2 and multiply together to get negative 3. If they multiply together to get a negative number, if the c value is negative, then they have to be alternate signs. So I'm going to need a plus 3 and a minus 1 in order to multiply together to get negative 3, but add together to get positive 2. Number 3, we have x squared plus 6x plus 8. So I'm looking for two factors of 8 that add together to get 6. I have 1 and 8, 2 and 4. The only number between 2 and 4 is 3, and 8 is not divisible by 3, so I have all the factors here. The c value is positive, so both of the factors are negative or both of the factors are positive. Notice that a positive 2 and a positive 4 would give me a positive 6. So I'm going to assign my x values to the left-hand position, and then I'm going to assign a positive 2 and a positive 4. And if you FOIL that out, you will, in fact, get back x squared plus 6x plus 8. Number 4, we have 12x minus 8x plus 12, excuse me, not 12x, x squared minus 8x plus 12 is equal to 0. So we're looking for two factors of 12 that add together to get negative 8. We have 1 and 12, 2 and 6, 3 and 4. This is a golden situation where you have consecutive integers at the bottom as bottom factors. There's no whole number in between 3 and 4, so you know that you have all the factors there. And we're trying to get negative 8. So we want negative 8, but the c value is a positive 12. That tells me that the two factors have to both be negative or both be positive in order to result in a positive product. Notice also that positive 2 plus a positive 6, a negative 2 plus a negative 6 will give me a negative 8. So I'm going to write out my parentheses, set them equal to 0 as the equation is, assign the x's into the left position, and then I need a negative 2 and a negative 6 in order to make a negative 8. If you have any questions, then please let me know. Otherwise, let's take a look at when a is not equal to 1. So this is where you have to consider not the factors of just c, but the factors of the product of a times c. You also need to consider the factors of a because your leading coefficient, your leading monomial has a coefficient now. That coefficient itself needs to be broken into factors to be coefficients of the x's in the left-hand position of the binomial. So when you write out your parentheses, now in front of the x's you're going to have numbers. So we have two things to consider. So we're going to first consider our factors of a and our factors of a and our factors of a times c. Sorry, I've been talking for a while. And we need two factors of a times c that add together to get b and that work with factors with one set of factors of a. The factors of a that we choose, we're going to have to reduce our a times c factors by those numbers because they're going to affect the inner times inner and outer times outer combinations when we ultimately FOIL back to check. So let's look at this example. It sounds like a lot and it's a little tricky, it's a little guess and check, but it's really not that bad and it becomes a lot easier once you see a few examples. So let's look at this guy. 6x squared minus 4x minus 2 is equal to 0. So first of all, I'm going to examine two things. I'm going to get a list of factors of A. A is 6, so my factors are 1 and 6, 2 and 3. Notice that my bottom pair of factors are consecutive, so I know I have all the factors there. The second factor form, or excuse me, the second value I'm going to consider the factors of is A times C. A times C is going to be 6 times 2, which is 12. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Notice the C value is negative, so that means that the factors have alternate signs. So I need to add together alternate signed numbers, alternate signed factors of A times C in order to get negative 4. Notice that a negative 6 and a positive 2 would produce a negative 4. And then the second step is to look at my factors of A. I have 1 and 6, 2 and 3. 2 and 3 work really well with 2 and 6 because 2 is divisible by 2 directly, 6 is divisible by 3 as well. Goes into 3 goes into 6 2 times. So in order to factor now, I start the same way. I'm going to just draw my parenthesis pairs. But now I need to assign x values with coefficients of 2x and 3x based on my determination of which factors of A are workable with my factors of A times C. Or in other words, which factors of A can be divided into the factors of A times C. I need to be able to recognize that the outer times the outer, that 2 is going to affect the other outer position. Oops, I'm sorry. And then I also need to understand that this 3x, that coefficient of 3, is going to affect these inner positions. So when I choose my factors, I have to choose the placement carefully because I want the 6, which is divisible by 3, to be associated with the 3. I want the 2 that's going to be associated with the 2 to associate with the 2. Now, because each of these values are now necessarily off because they're increasing, they're now being multiplied by an additional value, because they unto themselves multiply into 12 and they add into negative 4. So now we're increasing 6 by a factor of 3 and we're increasing 2 by a factor of 2. So you have to massage that difference away by reducing the values, reducing the factors by the coefficients that they're going to be multiplied by. So this is going to reduce, and what did I say? We need a negative 6. So this guy should be, let me go back to red. This guy should be negative and this guy should be positive because I need a negative 6 plus a positive 2 to get a negative 4. And so now this guy is going to simplify into 2x minus 6 divided by 3 is 2 times 3x plus 2 divided by 2 is 1. Now we could FOIL out to make sure that we did this correctly. First times first would be 2x times 3x. Outer times outer is going to be 2x times 1. Inner times inner is going to be negative 2 times 3x. And last times last is going to be negative 2 times 1. 2x times 3x is a 6x squared. 2x times 1 is a 2x. Negative 2x times 3x is a negative 6x. And negative 2 times 1 is a negative 2. Positive 2x minus 6x is going to give us a negative 4x. And so notice that we get back exactly what we started with. This is exactly the same as what we started with up here. And so this would be, this checks out, and so this is correct. That is the factored form of 6x squared minus 4x minus 2 is equal to 0. If you have any questions, then please let me know. Now I'd like you to try. So I'm going to give you 4 minutes. I'd like you to factor the following quadratic, and if you feel so persuaded, then you can also solve for x. You would have 2 answers. I'll keep track of the time in the upper right-hand corner. Okay, so recognizing that our a value is equal to 9, we're going to factorize our a, or we're going to find the factor pairs of a. So our factors of 9 are 1 and 9, 3 and 3. Our factors of a times c is 9 times 2, which is going to be 18. So our factors of 18 are 1 and 18, 2 and 9, 3 and 6. Notice that a positive 6 and a negative 3 will give us a positive 3, which is our b value. And also notice that 3 and 3 will work with the factors 3 and 6. So I started by placing the a values because I can't change those. So I started placing the factors of a as 3x and 3x into the left positions of the parentheses. And then here, because they're both being affected by coefficients of 3, it really doesn't matter technically which place you put them because the coefficients are the same number. But then I placed the 6 and the 3, making sure that the 6 was positive, so the result when they sum are positive. And then I divided each of those factors by the coefficient that they're going to be affected by. The inner times the inner and the outer times the outer are going to be multiplied into each other. So I need to reduce them by the coefficient that I placed in front of the x's. And so your answer here should be 3x plus 2 quantity times 3x minus 2. If you have any questions, then please let me know. Otherwise, I'll give you 4 minutes. Please look at number 2. At about a minute in, I'll start to solve just to keep pace. I'll try and do one more before the end of session today. Okay, so 15x squared minus 9x minus 6. If we're factoring here when a is not equal to 1, a here is not equal to 1, it's equal to 15. So we need to consider the factors of a, which are 1 and 15, 3 and 5. And then we also need to consider the factors of a times c. 15 times 6 is 90. The factors of 90, there's quite a set. 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, 9 and 10. Notice that 6 and 15 can be combined in such a manner that produces negative 9, namely a negative 15 plus a positive 6 will give you a negative 9. So, and then also notice once I choose my factors of a times c that I need to work with, that gives me enough information to choose which factors of a I need to work with, because 15 and 6 are both divisible by 5 and 3. So I'm going to place my a factors first, putting them in the left position, and then placing the other factors of 15 and 6 into the right position. But remember that I need to decrease those factors by the coefficients of the x values, because they're going to be manipulated when the outer times the outer and the inner times the inner values are multiplied. So simplifying here, 3x minus 15 over 5 is going to turn into 3x minus 3, and 5x plus 5x plus 6 over 3 will reduce into 5x plus 2. So our answer is 3x minus 3 quantity times 5x plus 2 is equal to 0. If you have any questions, then please let me know. For the sake of time, I'm going to give you 3 minutes, but I'll start to solve a minute in, and then we'll go through it, and that'll bring us up to time for today's session, but we'll get back into this on Wednesday. So 3 minutes. Okay, so our A value here is 6, so the factors of 6 are 1 and 6, 2 and 3. A times C is going to be 6 times 12, which is 72. 72 contains quite a few factor pairs. We have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and then finally 8 and 9. 8 and 9 will give us the difference that we are looking for of -1. We want to get a negative, or B value here is -1, so a -9 and a +8 will get us that. So from there, I can choose my factors of A that I'd like to work with based on the factors of A times C. I can see that 2 and 3 work well with 8 and 9 because 8 is divisible by 2 and 9 is divisible by 3. So I choose the factors of A that I want for as 2 and 3, and I assign those in the first left-hand position of my parentheses. Then I'm going to assign the 9 and the 8 so they work with the coefficients that they're going to be affected by. And then ultimately, I need to massage those numbers or reduce those numbers by the same factor that they're going to be increased by, because the inner and the inner and the outer terms are now going to have an extra coefficient involved. So I need to divide the 9 by 3 because the 9 will be multiplied by 3 in the inner times inner calculation. And I need to reduce the 8 by a factor of 2 because it's going to be multiplied by a coefficient of 2 in the outer times outer calculation. So 2x minus 9 over 3 times 3x plus 8 over 2 reduces to 2x minus 3 quantity times 3x plus 2. If you have any questions on anything that we've done today, then please let me know. Otherwise, if you find these videos helpful, please like and subscribe to my channel. I'm here for you guys every Monday, Wednesday, and Friday. Reading days are on Tuesday, and the writing skills days are on Thursday. Also, you can see my social media in the description below. My Twitter, Instagram, and Facebook page are just devoted to the tutoring channels. Right now I'm doing SAT prep questions of the day. At some point I'll expand those into more questions, but you can follow and friend me there, and that's where I'll give you any updates on the class or any changes, anything like that. But otherwise, Tater Tot, Dr. Tot, would you like to say goodbye to everybody for a cookie? Come on, you got to earn that cookie. Let's say goodbye. You say bye? Yeah, you say bye. That was one more time. Bye. Say bye. Okay, good job. Thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all on Wednesday.